Hello everyone, my name is Robert Nieto, and I'm going to be going over part 3 of the project for statistics, which is the predictions portion. So we're going to start off with question number 11, which is use the whisker plot and estimate the shape of the distribution. So basically we took our data set that we talked about in the previous video, and we plugged it into StatCrunch, and we created a box and whisker plot. And here's a picture of the output that we got. And we used the IQR. So we stated we have an IQR near the maximum values and the minimum value is 18. Hence, since the IQR is near the minimum values, the likely distribution is skewed to the right. In question 12, we do have to look back at question 11 because it's asking us to use either the empirical rule or Chevyshev's theorem to provide a prediction on the spread of data that is within 3 standard deviations away from the mean. So we found that in question 11, our distribution is likely to be skewed to the right. So that's why we stated in question 12, in question 11, we concluded that the distribution is likely skewed to the right. Hence, we are going to be using Chevyshev's theorem. So here is the formula for Chevyshev's theorem, and we're going to be finding k, which it's asked that we find 3 standard deviations away from the mean, so k is going to equal 3. And when you plug it into this formula, we were getting the output of 88.89%. So then to find the interval, we take the mean plus or minus 3 sample standard deviations, and we went and plugged it in. So our mean is the mean that we previously talked about, which is 48.03 plus or minus 3, and our sample standard deviation is 16.5453. And after plugging all that in, our output was negative 1.606 and 97.666. So then we have to state our conclusion. By Chevyshev's theorem, we have at least 88.89% of data within 3 standard deviations above and below the mean, and this interval is 0 and 98 years. This is because we're using years, so we can't have a negative, and we just decided to round up because it's basically 97.6, so rounds to 98. Question 13, create a confidence interval for the population mean using 90, 95%, or 99. Provide the critical value, sketch of the critical value, and the standard error. So first we're going to start off by stating our confidence interval. So we are going to be using the 90% confidence interval. We're stating our parameters, which n is equal to 300. Our mean, which we said before, is 48.03. Our sample standard deviation, 16.5453. Our confidence level, which is equal to 0.90. Our degrees of freedom we found by taking the n number of values and minusing it by 1, which is equal to 299. Our alpha is equal to 0.10, and alpha divided by 2 is equal to 0.05. We used a applet to find our t-score. We are going to do a t-score because we don't have the population standard deviation. We only have the sample standard deviation, so this is going to be a t-score. So the critical value is equal to 1.6500. So then we have to find the standard error, and this is the formula to find standard error. So we just went and plugged in our parameters, and after our calculation we got 1.576. So then we go on to find the confidence interval. So the formula is going to be the mean minus standard error, and then the mean plus the standard error. So mean 48.03 minus 1.576, and then 48.03 plus 1.576. And after our calculation, we were able to get 46.454 and 49.606. So again, after rounding up or rounding down, the 90% confidence interval for mu is 46 and 50 years old. Just to check our work, we went and took a screenshot of what our TI output was and placed it here. Now on to question 14. We're going to be creating a confidence interval for the population standard deviation using 90, 95, or 99 levels of confidence. Provide the critical value. Alrighty, so let's start off by stating what confidence interval we're going to be using, which is we are going to be using the 90% confidence interval. Stating our parameters, which is C is equal to 0.90, our alpha 0.10, and our alpha divided by 2 is 0.05. So for this one, we're going to have to be using the chi-squareds. So we use this applet to find our chi-squareds. So we plugged in our degrees of freedom and our confidence interval and our level of confidence. And we were able to get the chi-squared to the right being 340.328, and our chi-squared to the left being 259.945. Again, our n is 300. Our sample standard deviation is 16.5453. So now to find the confidence interval, this is the formula that you would use to find the confidence interval. So we just went and plugged in our numbers. And after our calculation, we got 15.508 and 17.745. So after rounding, the 90% confidence interval for the population standard deviation is 16 and 18 years of age. To check our work, we did a StatCrunch output, and just to make sure that everything that we got was right. Now on to question 15. Design a hypothesis test for the mean, proportion, variance, or standard deviation. So our claim, first we have to state our claim, and our claim is that the mean is equal to 48.03. We don't have the population standard deviation, so we will have to be using a t-test. Our claim, which is mu is equal to 48.03. Then we state our HO and our HA. HO, mu is equal to 48.03. And then HA, mu is not equal to 48.03. Our critical value is exactly what we found in the previous. So our critical value, alpha is equal to 1.65. Our C is 0.90, and our alpha divided by 2, which is 0.825. We used the T calculator from StatCrunch. We went and plugged it in just so that we could show our critical value here. And our critical value, T, is equal to plus or minus 1.65. Now on to find the test statistic. We just stated our parameters here. Mean equal to 48.03, mu equaling 48.03, sample standard deviation 16.5453, n equaling to 300, and our confidence being 0.90. So this is the equation that we use to find the test statistic. And after the calculation and plugging in our numbers, we got it to equal 0. So in our conclusion, we fail to reject because the test statistic T equaling plus or minus 1.65 is equal to 0 and is in between the critical value equal plus or minus 1.65, when the confidence is 0.90. Yes, our original claim contains equality, fail to reject HO. There is not sufficient evidence to warrant rejection of the claim that mu is equal to 48.03 years. As for question 16, like we've seen in our question number 10, we did have a couple data sets. If I can pull that up here. So here are our data sets here, the systematic sample, the convenience sample, and the stratified sample. Basically, we just took all of these separately and we placed them in StatCrunch, and we were able to get our standard deviation, our variance, and our mean. So the calculations were as follows, as well as here are the formulas for how you would do it by hand. But again, we put it into StatCrunch. So for the systematic sample, 43, for the mean, standard deviation, 16.58, and variance, 275.1. Convenience sample was as follows, and then the stratified sample was as follows. Alrighty. And now on to question 17. Use the results from 7, 8, 9, and 16 to test the claim that at least one of the samples is from a different population mean. So our claim is that at least one of the samples is from a different population mean using the alpha of 0.05. So first we got to state our HO and our HA. Our HO, mu1, mu2 is equal to mu3. Our HA, at least one of the populations means is different. So then it's time to get our critical value. So for the critical value, the numerator equals k minus 1. So our k is 3. So 3 minus 1 is equal to 2. For the critical value, for our denominator, it's n minus k. Since there was 30 values, and k is still equal to 3. 30 minus 3 is equal to 27. So to find the test statistic, we did use a StatCrunch output. We used the F calculator, and basically we plugged in our numbers and our degrees of confidence, because obviously we said that we were using 0.5. So the critical value, our F is equal to 0.0514, and F is equal to 3.3541. We also had the analysis from the variance results, and this is the calculations that we got, all from StatCrunch, test statistics, F and P. So after that, the p-value is right here, and the f-stat here. So in conclusion, fail to reject HO since the p-value is equal to 0.5118 is greater than our alpha, which is 0.05, using confidence of 0.90 and an alpha of 0.05. There is not sufficient evidence to conclude that at least one of the population means is different. And that is the part 3 for our project for statistics. Thank you.